So here we can discuss what is electric potential. So electric potential generally represented by capital letter V. It gives the magnitude of work done per unit charge in moving a charge from point A to point B. So first equation clearly explains VAB. Electric potential VAB is equal to WAB, that is the work done to move a charge from A to B, to move charge Q from A to B, okay, divided by Q, that is work done per unit charge in moving the charge from point A to point B. So this is equivalent to, this is a main equation connecting V and E, because here you can see that it is a negative integral of E dot dl with the limits A to B. Okay, and the unit is volt, and also you can note that from this equation all these are dealing with scalar quantities. Here also you are taking the line integral. So all these are just magnitudes, and electric potential is a scalar quantity. Its unit is volt. So the main equation that we learned here is VAB equals negative integral E dot dl from A to B. Okay, so line integral of electric field intensity will give you electric potential. Negative line integral of electric field intensity will give you electric potential. Electric field intensity E, it is a vector quantity, but electric potential V is a scalar quantity. So you can write the other way also. We wrote V as negative integral of E dot dl. Similarly, E can be written as negative of gradient of V. Okay, by taking the derivative of V, you will get the components of E. So again, splitting the concerning the magnitude part, you can write like this. E is a vector quantity and you are taking the gradient of V to get E. That means Ex, the X component will be minus dou V by dou X. Y component of E will be minus dou V by dou Y. And Z component of E will be negative dou V by dou Z. E is a vector quantity, V is a scalar quantity. E is electric field intensity and V is electric potential. Again, the unit of E is Newton per Coulomb and V, the unit is volt itself. So these are the two important equations connecting E and V. One is V is equal to negative integral of E dot dl and E is equal to minus del of V or negative gradient of V. Okay. Another thing is, you know that the potential difference between 2 points is independent of the path taken. You know that VAB is negative integral E dot dl A to B. Similarly, VAB will be again negative integral with the limits A to B. Here the limit will be negative integral A to B, and here the limit will be negative integral B to A. So they are linked with a negative sign. So the potential difference between AB is independent of the path taken. VAB is minus VAB. VBA is negative VAB. So when you take to one side, you can write VAB plus VBA is equal to 0. And you also know that it is a closed line integral of E dot dl, because this is how you connect V and E. Okay, so like VAB, when you write VAB or VBA, you give the negative sign. So this is a closed path. B to A, then A to B. So as it is a closed path, you can equate this as closed line integral of E dot dl, and that is 0. Why? Because VBA is minus VAB. So adding both, you will get 0. So this is an important equation. That's the closed line integral of E dot dl is equal to 0. Okay. Now you are applying Stokes theorem to this equation. How to apply Stokes theorem? Line integral of E dot dl, on applying Stokes theorem, you can convert this to surface integral. So surface integral of curl E. This line integral of E dot dl is equivalent to surface integral of curl E dot ds. So it can be written like this. Line integral of E dot dl is equal to, on applying Stokes theorem, you can write it is equivalent to surface integral of curl E dot ds. Both are equal to 0 because we got the value as 0 here. So from this, what you can conclude? Curl E is equal to 0. So curl E is equal to 0. This is the second Maxwell's equation. So first Maxwell's equation was derived from Gauss' law, which was del dot D is equal to rho. This is the second Maxwell's equation, that is curl E is equal to 0. Okay, so this is how you derive the second Maxwell's equation from the relation connecting VAB and E, electric field intensity and potential. Now let's learn another term called J, that is current density. Current density. If we take delta I as a current that is flowing through a surface delta S, then current density is given by delta I by delta S. Okay, so current density means current divided by area. In simple definition, we can say current per unit area. Delta I by delta S will give you current density. Now the total current, always to get the total current you have to multiply by area. So multiplying by area, it is equivalent to, when the area is unknown, what we do is we go for surface integral. We integrate it over the whole area. So I is equal to surface integral of J dot ds. This is an important equation. J is current density. So to get current from J, you take the surface integral of J dot ds. Next is continuity equation. Okay, continuity equation. According to the principle of charge conservation, the time rate of decrease of charge within a given volume must be equal to the net outward current flow through the closed surface of the volume. That means, as we all know, rate of change of charge is current, that we know. Rate of change of charge dq by dq by dt will give you current. So here you can check current, you just check these two. I is equal to minus dq by dt. Okay, rate of change, negative rate of change of charge will give you current. And you got an equation current connecting I and J like this. I is equal to surface integral of J dot ds. So you write it as current coming out of a surface, I out, is equal to surface integral of J dot ds, where J is current density, and this current is equal to minus dq by dt, where what is Q? Q is the total charge enclosed by the surface. Okay. Again, on applying divergence theorem, what you can do, surface integral is converted to volume integral. So surface integral of J dot ds can be written as volume integral of divergence of J. So surface integral J dot ds, we rewrite it as volume integral of del dot J dv, that is equal to this minus dq by dt. Okay, but there is another equation for Q, that is Q can be written as volume integral of rho v dv. So minus d by dt of Q in can be written as minus d by dt, we take outside. Q is replaced by volume integral of rho v dv. And taking the d by dt term inside the integral, you write negative volume integral of minus dou rho v by dou t. Okay, because rho v is not a function that is depending only on t. So because of that, d converts to dou, becomes a partial derivative. Thus, minus dq by dt, that is minus d by dt of volume integral rho v dv, is equal to negative volume integral of dou rho v by dou t. Okay, now you can relate these two equations. Both are volume integrals. So removing the integrals, you can connect these two terms. That is del dot J is equal to minus dou rho v by dou t. You can link these two. Del dot j is equal to minus dou rho v by dou t. Okay, this is how you get it. So this equation is called continuity equation. Del dot j is equal to minus dou rho v by dou t. Continuity of current equation.